So this session is about the design of raft for the high-rise building. And in this session, we will be modeling the raft, and then we will design the raft in the safe as per ACI 31814. But for the design of the raft, we will select the superstructure of a 12-story building, which is in the category of high-rise building. And before going towards the modeling, let me show you the superstructure for which we will be designing our raft. So this is the 12-story building in which we have this typical 24, 25 cross 20 grid, which is normally the used grid in the by the architects in the shower normally, and it varies. It may be 25 20 or maybe 20 25 or maybe 20 cross 20. So I have taken this typical grid, which is 25 cross 20, which is normally what we get from the architects. Right, so you have to design the superstructure, and then for the raft you have to again draw the slab at the base, and all of this procedure which we have done in the past we have to follow. Right, so we have selected this 12-story commercial building, and this is the stepwise procedure for the design and modeling of the raft. First of all, you have to import the reaction from ETAB as F2K file to a safe, or you can draw the mat area in the ETAB, and after that you export that loads into the safe. You can directly export the loads to the safe, and in the second step you can draw the mat area in the safe as well, or you can draw it in the ETAB. Right, so let us draw it in the ETAB to make our job easy. So you have to go to the base, and then we have to go to the draw and draw the floor area, and click on the draw rectangular, and this is the one edge column, this is the other. So you have to draw the raft. So this is the opening, so you have to select the example. This is, let us say, 6 inches. So this is the raft, and this is the raft is at the center of this column, and the column for this building is 36 cross 36. So you have some space on the outer edge, so you can expand this area by 18 inches all around this raft, and you have to go to the shell and expand this area into 18 inches all around. Right, so now this is the actual raft which you will be drafting in your AutoCAD by the draftman. Right, so this is the first step, which you have to draw the raft, and then you have to define the slab thickness. Click on the new property, and let us call the raft 36 inches. So there is a thumb rule. Let me also give you the hint for the thumb rule to initially select the thickness of the raft. That if there is the raft requirement for a high-rise building, then you have to multiply the number of story with 3 inches. Right, so we take the thumb rule is that we take 3 inches per story. So we will take 3 inches, and this is 12 stories, so we will multiply with 12. So we will take initially 36 inches thick raft initially. Right, so this is the 3000, and we will take the thickness is equal to 36 inches. So this is the thumb rule, and after the analysis and design you have to change, increase or decrease the raft thickness as per the requirement. Right, so this is done. Now you have to run the analysis and again export the file into the safe, which we have done in the past. So I've already done that to save the time. So this is the file in which I have run the analysis, and this is the raft 36 inches. Now you have to export this file as again story F2K file, and you have to select the floor loads and above loads, and this is the basement, and you have to select the desired load combos and loads. and again you have to save it to the desired folder in which you want to perform the analysis and design. So this is the Raft, and you have to save, for example, this. Now again you have to open that file into the save. Right. So this is the file which I have already run. So the thing is that we have to again export the F2K file that you exported from ETAB, and you have to import in the save. Right. So the procedure is same, like just we did it in the past for the combined footing and associated footing. So let us repeat it again. So you have to go to the file and import the story. So this is the file. So now this is the Raft which have we imported from ETAB. You can confirm these loads by right clicking on this. So now you can, this is a dead load, this is live load, this is super dead load, and there is also the earthquake forces has been imported from ETAB. Right, so the next step is to define the subgrade modulus. The third step is to define the subgrade modulus to represent the soil. And we take the level bearing capacity, this time 2 TSF. And then you have to calculate the stiffness for the springs to represent the soil, which is the same procedure. And this time we are getting 158,688 pounds per cubic feet. And you have to assign this subgrade modulus to the Raft, right? So let us perform this. So you have to select all of the Raft and go to the assign support data soil property, and this is the soil 1 you have to modify, and we have to write 158,688. Right, so this is the value 158,688, and you have to click OK. Now the soil has been assigned to the Raft. So the next step is the analysis. Then we have to click on the run, that we have to confirm first the thickness, which I have tell you the thumb rule for the calculation of the thickness. But what the CI says, the made foundations are treated as two-way slab as per ACI code, and the thickness of the Raft is governed by the punching demand, which you already know. And as long as your punching issue, their punching is not an issue, then you can select any thickness, right? So the code recommends that you use the thickness not less than 6 inches, which you already know. And this is the statement which we have seen previously, right? So initially we have given 36 inches Raft on thumb rule, and the fifth step is to run the analysis with the all load combinations which have been imported from the ETAB, right? So now the next step is to run the analysis. So to save the time, I have already run the analysis. These are the same properties. If I show you the cell thickness, it is 36 inches, right? And all of the other properties are the same. Now the next step is for in the design phase. This was all about the modeling. Now the design phase, the first step is to check the punching shape, because the thickness is governed by the punching, and the demand to capacity ratio should be less than 1, which you already know. So if the demand to capacity ratio is greater than 1, then we have two options, which you already know. You have to increase the depth of the Raft, or you have to design the integral beam, right? There is also a third option, that you can increase the area of the Raft, but if it is restricted to this much area, then we have only these two options, right? So the second step is the reinforcement, which we will be designing our Raft as per ACI code in the as per the section 13.3.4, that you can design the made foundation and combined footing as a two-way slab. So let us go to the save and check the punch check, and now you can see at the periphery, at the edges, there is no calculation of the punch, because we have a basement wall, shear wall, retaining wall, and at the center you can see the ratio is greater than 1 if you right click on it. So the governing load combination is the 1.2D plus 1.6 live, and the ratio is greater than 1, which is 1.16. It means that you have to either design the integral beam for it, or you have to increase the depth of the footing, right? So let us unlock this model and let us adopt option 1, in which you have to increase the thickness, and let us make it 42. And again run the analysis. So this is the option in which you can safely transfer the loads to the foundation by increasing the depth of the footing of the raft or design the integral beam. So at first we will adopt option 1, we will increase the thickness, and then we will check again the punching. And after that we will also design the integral beam if you don't want to increase the depth of the raft, right? So analysis has been done. Now you have to again check on the punching. Now you can see that the punching ratio is now less than 1. And if it is almost 0.91, right? So you cannot decrease the thickness from 42, or there is no need to increase the thickness from 42, right? So this was the whole story about the option 1. So what if you adopt option 2, right? If you do not want to increase the raft thickness from 36, you want to work with 36 inches and you want to design the integral beam. So the SAFE has the capability to design the integral beam for you. Again, you have to make this raft 36 inch. And you have to again run the analysis. And check for the punch check again, right? So again, it will be greater than 1, but this time we don't want to increase the raft thickness. We will go for the design of the integral beam, right? So this is the design for the punching check. This is the ratio greater than 1. So now in order to design the integral beam, you have to select all of the raft. You have to go to the design and click on this punch check overrides and keep all of these as default. Now click here, the reinforcement allowed, it says no, so you have to make it rebar ties and make it orthogonal, and write the bar yield strength, the bar dia, which will be used 0.75, number 6 bar, and the spacing will be using is 6 inches. Now click on OK. It says that the results will be deleted. Click on yes. Now again run the analysis. So now it is ready. Now click again on the punching. Now you can see instead of giving you the ratios, it's giving you some information. It says that it is 11 cross 2-3/4 at the rate 16 channel center, right? What does it mean? So let us right click on it. And you can see that at the end there is a punching reinforcement design in which says the rebar yield strength is equal to 60 grade 60 steel, and rebar die is 0.75 inch. The number of rebar set it requires is 12, and the number of single leg strip per set is 2, and the typical spacing is 6 inches, right? So what does it mean by number of rebar sets and the number of single leg strips? So it means that you have this is the beam, right? And this is the cross section of the beam. This is the right. So what the ETAB is mean by the number of set, it means that this top one longitudinal bar and this bottom, these two are called as one set, right? So if you provide 2 bars at the top and 2 bars at the bottom, it means you have provided 2 sets. This is one set and this is another set. So it is asking about the 12 sets. So you have to provide 12 sets. It means this is 1, 2, 3, 4, 5, 6, right? So this is the 6 sets that will be running in the one direction, and you have to provide a single, this is the single leg stirrup. So you have to provide reinforcement like this. So this is the meaning of the ETAB shape, right? So if I show it to you in the plane, so this is the one direction, this is the other direction, and this is the column, right? So you have to provide overall 12 sets. So you have to provide 6 sets in this, right? So this will be 1, 2, 3, 4, 5, 6, and 6 will be in this direction. So this will be total 12 sets required by the punching demand, right? So this is the overall procedure for the design of integral beam in the safe, and you have to provide these strips at the rate 6 inches center to center, right? So this was an extra information I wanted to share with you guys, that if you do not want to increase the thickness of the raft, so what is the next step to design it for the integral beam. So this was the whole story about the design for the integral beam. You can design the integral beam like this. So let us again change this thickness to 42, because we were designing with the increase of the thickness for the raft. Again, you have to run the analysis, and you will move towards the design of the raft, right? So for the design of the mat foundation, again, you have to design it as a two-way slab as per ACI 38014, right? So before designing it in the safe, again, you have to check the minimum reinforcement as per the ACI code, and as per please turn off your mic, please. Hussein? So as per ACI 31814, section 13.3.4.4, minimum reinforcement should be provided as per table this, which is table 8.6.1.1. That for the non-precious two-way slab, this is the minimum criteria, which you already know, that if the grade is steel grade is greater than or equal to 60, then this is 0.0018 and 0.0014. So in our case, we have FY 60 and H is equal to 42 inches. So the second case is applicable. And if you calculate the minimum reinforcement as per these calculations, so you have to calculate the 0.0018 into which is the 42, and this is the 12. So it is 0.9. Right, so it is 0.9 inch square per foot, which you have to provide as the minimum reinforcement. The second one is the 0.004, so we will make that 4, and it is 0.71. So you have to write it here, it is 71, and this is not 39, this is 40. Right, so you have to find the spacing from it. It is, the first one is 0.9. So if you use number 8 bar, right, and if you divide with 0.9 and you multiply with 12, it gives you 10 in center to center. So you have to provide number 8 bar at the rate 10 center to center at least, and this is the governing, right? This is not the governing. You have to provide this much reinforcement as a minimum reinforcement. right? So let us go back to the ETAB and let us change the design preferences minimum clay covers, and for the top it is 1.5 and for the bottom we take normally 3, and click on OK and click on yes. So again run the analysis in order to calculate the reinforcement for you. Right, so let us check the reinforcement, and we will uncheck this minimum reinforcement because I've already explained the reason for it in the previous session. And let us check the bottom reinforcement pattern. And this is the pattern for the bottom in direction 1, which is obvious that we have the maximum moment in the under the columns, and it requires 0 reinforcement at the center. Okay, right? But at the top, it will need the reinforcement at the center, but less reinforcement at this. These are the location of the columns, and it will require 0 reinforcement under the column for the top. Right? So let us design this reinforcement, because you have to check the pattern first before designing your raft. So this is the pattern in other direction, which is very obvious and very accurate, right? So let us design the bottom reinforcement, and we will provide the minimum reinforcement, which is number 8 at the rate 10 inch center to center. And if you provide number 8 bars at the rate 10 inch center to center, so many of the reinforcement are satisfied, but still it's asking under the columns, right? The bottom is under the columns, and this is the direction 1, and this is the direction 2. If you want to use number 6 bar, you can also use number 6 bar at the rate 6 inch center, right? You can also use that as well. So let us use this number 6 bar at the rate 6 inch center as the first layer. So the first layer will be overall layer in which the bar size will be number 6 and its spacing will be 6 inches center to center in both the direction, in X direction and in Y direction, right? So let us go back to the results, right? So in the bottom layer, we are designing in different layers. In bottom layer, which is continuous layer, we will use number 6 bar at the rate 6 inches center to center, right? So now you have already provided layer 1. Now the contours you are seeing is the reinforcement for the second layer. And how do you calculate the length for the bars in the second layer? That we have to check, for example, in direction 1, this is the direction 1, you have to provide the reinforcement in this direction. So you have to check the length in this. This is the length of the bar in direction 1. So you have to click in here and you have to check the coordinates, right? Check at the corner, the coordinates in X is 43 and at the other end it is 56, right? So it is almost 13. So you have to go for the 15 or you can go for the 13 as well. Normally you have to go for the 15 because the bar length is 40 feet. So if you provide 15, so it will be very accurate and there will be no wastage of the reinforcement, right? So in X direction, the length of the bar comes out to be for the second layer is 15. Similar for the second direction. If you check the direction for the second, so it is very less because you have to provide reinforcement in this direction, right? So you have to check the coordinates this time for the Y. The Y coordinates is 56 and the other is 63, right? So if you minus 63 from 56, it comes out to be 7 feet. So you have to go for the 8 feet or 10 feet in order to for the proper containment of the 40 feet length bar. So we will take the 8 feet and we have to provide the again number 6 bar in the second layer, right? So if you provide number 6 bar in the second layer, you have to insert the spacing in here is 3 inches, right? So some of the reinforcement has been removed. This is the direction 2 and this is the direction 1, right? So In the second layer, we will be using number 6 bar at the rate 6 inches again center to center. But in software, you have to insert the spacing 3 inches in order to represent 2 layers in the software, because the software do not have the capability to design the reinforcement in different layers, right? So again, if you want to provide a third layer using number 6 bar, so again you have to uh, half the spacing which you have provided in the previous layer. So you have to half this layer by 1.5 inch and you have to apply, right? So now you can see again it's asking some of the reinforcement because the number 6 bar in the third layer is not working for us. So we will change this bar. So now you have to calculate the spacing and to check in the software. At the first you have provided in the first layer, you use number 4 bar and we have divided with the number 6, so it will be divided 0.5. So 0.88 inch square per foot reinforcement you have provided in layer 1. In layer 2 you have provided again, this is the bar dia and this is the spacing 0.5. Again you have provided 0.88 inch square per foot in the second layer. Now you want to increase the reinforcement in the third layer. You want to provide number 8 bar with the spacing of 6 inch center to center, and you want to provide 1.6 inch square per foot reinforcement. Now you have to sum up all of these reinforcement you want to provide, right? So you will provide overall reinforcement of 3.36 inch square per foot. So now how do you give this detail to the software? You have to calculate the bar spacing with the bar size. If you use number 8 bar in the software, which is its area is equal to 0.8, and you have to divide this 0.8 with the total reinforcement area you want to provide, and you have to multiply with 12. So 2.85. So now you have to select number 8 bar and you have to insert 2.85 and you have to apply and to check whether this will work or not, right? So still it is asking some of the reinforcement, but it is very negligibly small, right? If you want to provide number 4 fourth layer for the 12-story building, so it will become uneconomical. You can see the reinforcement in here, it shows 0.07. And if you calculate this reinforcement, for example, if you provide number 4 by divided by 0.07, and if you divide that, and if you multiply with this with 12, so it means you have to provide number 6 bar at the rate 75 inch center in the fourth layer, which is very negligibly small. Although you can increase the decrease the spacing if you want to decrease the spacing from 6 inch to 5 inches, you can also do that. You can divide by 5, multiply with 12. So overall we have to provide 3.68 inch square per foot, and the spacing will become 2.6. So now you have to insert in here this 2.6 and click on apply. Now you can see many of the reinforcement has been gone, and this is still asking some of the reinforcement. It is, you can see, is very negligibly small. So normally we neglect that. This is the direction 1 and the other is direction 2. In direction 2 there is no reinforcement required if you provide 3 layers, right? So for the layer 2 which we have provided, we will be using 15 feet bar in X direction, 8 feet bar Y direction. This is how you calculate the length and the number of layers in the raft. In the third, we haven't calculated that. Let us calculate the length. What's 3? So the length in the Y direction, it is 75, and if you check it, it is 83. So it is almost 8. You will take 8 again. In the direction 1, it is again, I think it is will be 8 is 21 and it is 28, so 7, so we will take 8, right? So we will use number 8 bar at the rate 6 inches center to center, and we will take 8 feet bar in each direction. This is how you can play with the bar sizes and the calculate the bar length in different layers, right? So this was the whole story about the design of the reinforcement for the in the bottom. You can also check for the reinforcement at the edges, and you can give in your drafting the length of the bar if it is required at the edges, if it is not required at the edges or not, right? So this was the whole story about the bottom reinforcement, and we will start the design of top reinforcement for the raft in the next Zoom meet. I will end this meeting and I will generate another link so you can join again, so you can continue our session. Same.